Hello everyone, welcome back to our channel. Let's start the next very important subject, that is what? Spectroscopy. We all know that the chemical methods are generally used to determine the structure of unknown chemical compounds. In the late 1950s, we were used only chemical methods to determine the structure of different kinds of chemical compounds. After the 50s, the people were introduced a new physical technique is commonly called as spectroscopy. So what is the necessity to introduce this particular subject called as spectroscopy? The necessity is that what? Whenever we synthesize a particular chemical compound, we are going to process through the particular pathways or not. Right? Some reactions may be single step reactions, some reactions may be 2-step, 3-step, 4-step. In case of the natural products, we are going to have different kinds of the number of steps or not. It means that what? Whatever the chemical compound which we are synthesizing in the laboratory condition, that chemical compound is very precious in nature or not. Right? If the compound is precious in nature, then we should not lose the quantity of the substance or not. Suppose if you subject the particular compound to the chemical methods of analysis, what will happen? We cannot regain our chemical compound. That's why there is a necessary to introduce a physical technique. In case of the physical techniques, what happens? Whatever the compound which we are using for the determination of unknown structure of a chemical compound, after the successful determination of the structure of the compound, what should we get? We can regain our original compound. That is the use of the what? Physical technique. So, the spectroscopy is a physical technique which is useful for the determination of structure of unknown chemical compounds. Right? This is the main motto or main aim of the spectroscopy. The spectroscopy is a what? Physical technique which is used to determine the structure of a unknown chemical compound. The structure of the compound is very important or not. That's why the spectroscopy plays a very important role in the structural elucidation. Okay. Let's see the definition of the spectroscopy. What is the definition? It is the study of interaction between the electromagnetic radiation and sample. So in spectroscopy, what we are doing? We are taking the unknown chemical substance in the container. This is going to interact with what? Electromagnetic radiation. It means that what? Without losing the substance, we are going to get the data of the compound or not. That is the use of spectroscopy techniques. We all are familiar with the term called as electromagnetic radiation. The electromagnetic radiation is a kind of energy like heat and work. It is containing what? The combination of electromagnetic waves. These electromagnetic waves are what? Dual in nature. The particle nature and the wave nature. Right? Whenever we are saying the dual nature, particle nature and the wave nature means these electromagnetic waves are represented in this waveform or not. So the wave is going to have particular properties or not. What are the properties? Wavelength, amplitude, velocity, frequency and wave number. It means that what? All kinds of the electromagnetic radiations are going to have these properties: wavelength, amplitude, velocity, frequency and wave number. So what is the wavelength? How can we define the wavelength? Wavelength is the what? Distance between the two crests or the distance between two troughs. That gives what? Wavelength. Amplitude means what? The height of the crest or the depth of the trough is commonly called as what? Amplitude. Next one is the what? Velocity. Distance travelled by the wave in a particular time or a given time. That is what? Velocity. Next one is the what? frequency. Frequency, how can we define? The number of waves passed through a particular point in a given time. That is commonly called as what? Frequency. Wave number means what? The number of waves present in 1 centimeter distance is commonly called as wave number. So all these properties we are studying from the +1, +2 onwards. That's why there is no need to have a brief discussion of the particular functions which are related to the waves. Okay, the frequency is equal to c by lambda, wave number equal to 1 by lambda. If you want to relate these two, how can we write? Mu equal to c into mu bar, right? So these are the what? Some of the properties of the waves, right? If you want to calculate the energy, what is the formula according to Planck's quantum theory? E equal to h nu. That is E equal to hc by lambda. Hc into 1 by lambda, that is equal to what? Hc into mu bar. So what is the meaning of this particular equation? Whenever you know any one of these components, we can calculate what? Energy or not, right? So if you want to calculate the energy of any kind of the electromagnetic radiation, what should we know? We need to know any one of these components. That's why in different spectroscopic techniques, what we are using the terminology of wavelength, frequency, wave number, etc. So once we are using the wavelength, wave number, frequency means what? Indirectly we are using the energy or not. So always keep it in mind. Suppose in case of the ultraviolet visible spectroscopy, we will be discussing about the wavelength, right? The particular wavelength of the radiation. It means that what? If you know the wavelength, what should we calculate? Energy or not? So indirectly we are calculating the what? Energy. In case of the infrared spectroscopy, we are using wave number. So we are using wave number means what? Indirectly we are using energy or not. So in all cases, whatever the component which we are using in different kinds of the spectroscopic techniques, indirectly we are talking about the energy only. That you need to remember. Okay. So if you see the electromagnetic radiation, the electromagnetic radiation is the what kind of energy? It is associated with electromagnetic waves. The electromagnetic waves are composed of what? Electric field and magnetic field or not. So the electromagnetic radiation is going to have both the electric field and the magnetic field. Suppose if the electromagnetic radiation is propagated in this direction, x-axis direction. So what we are observing, the electric field will be in the y-axis direction and the magnetic field will be in the z-axis direction. What does it mean? It means that what? These two fields, magnetic field and electric field, both are perpendicular to each other and also perpendicular to the direction of the propagation of electromagnetic radiation. We all know that electromagnetic spectrum. The electromagnetic spectrum is a combination of the electromagnetic waves or not, depending upon their frequency or depending upon their wavelength. So what are those radiations? Gamma ray, X-ray, ultraviolet, visible, infrared, microwave and radio waves. These are the different kinds of the electromagnetic waves which comprised by electromagnetic spectrum. Okay, so in spectroscopy what we are doing, electromagnetic radiation is going to interact with your unknown sample. It means that what? In one spectroscopy, gamma rays will interact with the sample. In another spectroscopy, X-rays will interact with the sample. In another spectroscopy, UV visible light will interact with the sample. In another spectroscopy, infrared light will interact with the sample. It means that what? The interaction between the different kinds of the electromagnetic radiations and the unknown samples results the structural determination of your chemical compounds. So depending upon the type of the interaction, the spectroscopy techniques are divided in this way. rotational spectroscopy, infrared spectroscopy, Raman spectroscopy, UV visible spectroscopy, photoelectron spectroscopy, NMR spectroscopy, ESR spectroscopy, ORD and CD spectroscopy, mass bar spectroscopy, X-ray spectroscopy and mass spectrometry. In mass spectrometry, we are not using any kind of electromagnetic radiation. In mass spectrometry, what we are using? High energy electron beam. The high energy electron beam will interact with your unknown sample. Thereby, what kind of information we are getting? Molecular weight of the compound, molecular formula of the compound and nature of small groups which are present in the unknown sample. Already we had a clear discussion on mass spectrometry unit. Okay. If you want the complete details about the mass spectrometry, kindly go through the videos which are present in my channel related to the mass spectrometry. So let's see the remaining spectroscopic techniques. Rotational spectroscopy. In rotational spectroscopy, we are using what? Microwave radiation. The microwave radiation is interact with the unknown chemical sample. Thereby what happens? We will get the information about bond length, bond angles and atomic masses. The second one is what? IR spectroscopy, infrared spectroscopy. In case of infrared spectroscopy, which we are using what? Infrared radiation. Whenever the infrared radiation interact with the unknown chemical sample, what happens? We can detect the different kinds of the functional groups which are present in the unknown chemical sample. Okay. Next one is what? Raman spectroscopy. In Raman spectroscopy also we are using the infrared radiation. Thereby we are going to identify rotational, vibrational and other states in a molecular system. Okay. Next one is the what? Ultraviolet visible spectroscopy. Here we are using UV visible light. UV visible radiation. This is specially used for the what? Detection of chromophores. In generally, these are used for the identification of conjugated systems in the molecule. Okay. Next one. Photoelectron spectroscopy. In case of photoelectron spectroscopy, we are having two types. UV protoelectron spectroscopy, X-ray protoelectron spectroscopy. So here we are using UV light. Here we are using what? X-ray light. This spectroscopy gives the information about binding energy of the valence electron. This one is going to give the information about binding energy of the core electrons or inner electrons. Okay. Next one is what? NMR spectroscopy. Here we are using radio waves. This spectroscopy gives the information about what? Nature of nucleus. It may be a hydrogen, it may be a carbon, it may be a nitrogen, it may be a phosphorus. The nature of the nucleus is going to be identified by using the NMR spectroscopy. The next one is what? ESR spectroscopy, electron spin resonance spectroscopy. Here we are using microwave radiation. Thereby what we are detecting? The free radicals in the unknown sample. Okay. Next one, ORD and CD spectroscopy, optical rotatory dispersion and circular dichroism. Here we are using which light? Ultraviolet visible light. This is mainly used for the what? Determination of the configurations and the conformations. Nowadays, this chemistry is very much useful. Configurations and conformations. The next type of spectroscopy is what? Mass bar spectroscopy. Here we are using what? Gamma radiation. The gamma radiation is going to interact with the unknown sample. Thereby what we are getting? Concerned to energy states of the nuclei. How the energy states are formed is going to give. Next one, X-ray spectroscopy. Here we are using X-ray radiation. The X-ray spectroscopy is going to give the information about what? Absolute structure of the compound. What does it mean? Absolute structure of the compound means complete structure of the chemical compound. can be identified by X-ray spectroscopy. If you see remaining all spectroscopic techniques, each and every spectroscopic technique is going to give a particular information about the chemical compound, right? One spectroscopy is giving the nature of nucleus, another spectroscopy is giving the functional group detection, another spectroscopy is giving the bond length, bond angles, atomic masses identification. It means that what? None of the spectroscopic techniques is going to give complete information about the particular chemical compound. So, X-ray spectroscopy is the only spectroscopy is going to give the information about the structure of the unknown chemical compound, complete structure. So, you have a doubt in your mind that X-ray spectroscopy is going to give the complete information about the structure of the chemical compound. Then what is the necessity of the remaining techniques to study about the structure? The thing is that in case of the X-ray spectroscopy, what should we need? Perfectly crystalline solid material. Your unknown sample should be what? Perfectly crystalline solid material. Then only the X-ray is going to give the complete analysis of the structure. So, is it possible for us all the samples are converted into perfect crystalline solids? Is it possible? No. Why? Because we are having solid samples, we are having semi-solid samples, commonly called as what? Amorphous samples. We are having liquid samples and we are having gaseous samples. Different kinds of the samples are present or not. So, in order to identify the chemical structures of each and every kind of the sample, we need all kinds of the spectroscopic techniques. That's why there is a necessity to study all these spectroscopic techniques to determine the structure of unknown chemical compounds. Right? If you talk about the spectroscopy, as far as organic chemistry is concerned, we are going to deal with 4 spectroscopic techniques. The first one is what? IR spectroscopy. The second one is NMR spectroscopy. The third one UV visible spectroscopy, and the fourth one mass spectrometry. If you have the complete information about the IR, ultraviolet visible spectroscopy, NMR spectroscopy and mass spectrometry, 100% we can determine the structure of organic compound. We all know that comparing with the inorganic compounds, the percentage of organic compounds are higher. Nowadays, most of the compounds, 90% of the compounds are organic compounds or not. That's why, if you know the information of these 4 spectroscopic techniques, IR, UV, NMR and mass spectrometry, we can easily deduce the structure of the compound. Right? In this regard, already I had given the complete information about the mass spectrometry technique. Nearly, I prepared 17 videos in the form of 17 parts. Soon you are going to get all the 17 parts related to the mass spectrometry. In generally, you are going to get the information related to the mass spectrometry in alternative days. Every alternative day, you will get one particular video related to mass spectrometry. So, within the 34 days, you are going to have the complete information related to the mass spectrometry. Right? So, from the next video onwards, we will be starting the first technique, that is what? Infrared spectroscopy. How can we determine or how can we detect the functional groups in organic compounds? Right? Once the organic portion completed, it means that what? IR, UV visible, NMR, mass spectra. Once these 4 units are completed, then we are going to have a clear-cut discussion on remaining spectroscopic techniques also. Thereby, each and every chemistry aspirant is going to be benefited by using the spectroscopy topics.